is Cynthia, and I'm here with...
And my name is Rei Shimizu.
And we're going to be talking about building a distributed API gateway with a service mesh. So taking API gateway functionality and moving it into a service mesh. So let's go ahead and get started. So we're going to give you an idea of what we're going to be talking about. First, we're going to be talking about what a service mesh is, and what it provides. Next, we'll go over what an API gateway is and sort of degeneralize that term because it means a lot of different things to a lot of different people. It's, the name is sort of going through an identity crisis. Next, we'll be talking about Envoy, which is a particular implementation of a proxy that we will be using in this talk. So we just want to give sort of a quick forward about what it is. Next, we'll be talking about using WASM in Envoy, as well as why we would want to use WASM at all in order to build extensibility into these proxies. And last, we'll give a demo of adding API gateway functionality into a service mesh with Envoy. So like I said, let's go ahead and get started. So what is a service mesh? A service mesh is all about bringing a layer of standardization to the network level when you're dealing with lots of different services. So you can imagine in a sufficiently large company or maybe a medium-sized company, right, you have 20 different services, maybe written in 3 different languages, right? And you want to apply a policy across all of your services at once. It can be very hard to do that without any sort of layer there. For example, if you wanted to enforce encryption between all of your services, because let's say you had a new requirement pop up, right? It may be very hard to actually achieve that because you have to, implement a library, each in the 3 languages, and then you have to wait for all of the 20 services to adopt it. And then you have to test in each of the 20 services that they're all doing what they're supposed to do, i.e. the encryption is working the way you expect it to. With a service mesh, this problem is actually much easier because the idea is you have a single sidecar that sits next to every single service that actually does all of that complex logic for you. So this sidecar figures out how to do MTLS or service-to-service encryption, and your individual services don't have to figure it out themselves. This makes it really easy to add in new services. So if you want to add in a new service, perhaps written in a new language, you don't have to go build, a library to do transport encryption the way your company does it. You just let it talk to the sidecar, and the sidecar handles it all for you, right? This also is a really nice way to be able to query policies across the whole mesh because, again, you have one configuration source for how you do all your networking. This can be really useful also because it sort of abstracts networking logic away from application logic. So let's say you're moving a service into a new cloud provider or to a different cloud provider. Maybe you're adopting cloud. You don't have to go, redeploy all of your applications anytime you deploy a new service into the cloud. You can just send a configuration update that says, hey, route all of your traffic to this new service in the cloud, and it's just a single configuration update. You don't actually have to deploy a new version of your app or deploy an app configuration update, right, because they're decoupled. So it's much lower risk and much easier to make changes as time goes on. This is why a service mesh is really useful and why you would want one. So an API gateway is actually very similar to a service mesh in our minds, right? An API gateway just is going to be providing those consistent set of policies or things that you want to happen on the front door, right? So they're going to be doing rate limiting and maybe protocol translation or maybe authentications for users, right? So they're giving you that consistency at the front door, right there. They're giving you one front door that acts the same way so that way every single service behind it, doesn't have to figure out how to do like user authentication. It just gets the user authentication information in a header. It doesn't actually have to figure out how to do this. This consistency at your front door is also very useful. But it got us to thinking, if a service mesh and an API gateway are all about providing consistency at the networking layer, they're just at 2 different networking points, would it be possible to combine these 2 things into the exact same system so that way you don't have to maintain 2 separate systems? For example, if you want to change how authentication is done, you change it in one place and you don't have to go change, user authentication at the front door and service-to-service authentication for your sidecar implementation for your service mesh, right? Having one place to change that. If you get an influx of traffic, you no longer have to scale up your API gateway and your actual services behind the API gateway, you just scale up your service. And your services sidecar is handling all of that front door traffic as well as the service-to-service communication. We think there's a lot of exciting things that can happen here, and this is what an API gateway truly is. It's not something that is like combining responses, that's getting into feature creep territory, where it can be really hard to make changes because the API gateway is just doing too much. But when you think about an API gateway like most API gateways are, where they're just providing this consistent set of policies on the networking front door, it can also work really, really well as just being part of your service mesh sidecar, where the sidecars are just handling all of that transparently because they're doing a lot of the same things. They're routing, the logic is exactly the same from routing from a service in as well as a service-to-service communication, right? The routing is exactly the same. And in authentication, although it may be different, you're validating a JWT instead of a certificate, it's the exact same procedure, it's just authentication. You're just authenticating something different, right? But these two things can be combined without introducing too much feature creep. So, what is Envoy? For those of you who haven't heard of Envoy before, just know it's a very, very common proxy that is used in a lot of service meshes as well as API gateways today. In this session, we're going to be using Envoy as the sidecar for our service mesh. Some of you may be more familiar with something like Istio, which builds on top of Envoy and adds a new set of concepts that can help integrate Envoy into a service mesh system. For simplicity, we're just going to be using Envoy. If you're wondering why Envoy is so popular, right, it's very performant from the ground up, and it's very easy to introspect with first-in-class logging and monitoring. It's very, very easy to see what is going on. Next, it's also very extensible, so it's very easy for us to add in new functionality without too much work. It's got this idea of filters that we'll talk about more here in a second. And it's also got this great dynamic configuration system, which is called XDS, which will allow us to not only push updates very easily, but also track the progress of when they get applied. So it's very easy to see, from point A to point B, when the configuration update gets sent out, when it gets applied, and when it's actually been applied and is being used. And this works great. So, slide isn't updating. So if you're curious about building a distributed API gateway, my slide isn't updating. The idea is Envoy has this idea of filter chains. So an Envoy is going to be, it has a listener that is listening on a port and is going to have traffic coming on the inbound, right? And that listener is then going to pass off the traffic to a series of filter chains. And a filter chain is kind of a dense concept, but the basic idea is it's a series of filters, and each filter is going to do one thing to the request or response, and then move on. So for example, it may parse the request as HTTP, and then, let the router now match on HTTP level things, right? So it's going to validate that it's valid HTTP traffic and then continue on. Maybe you have another filter that then takes an HTTP header and validates the JWT and then passes it on, right? So you have these series of operations that are filters, and they get put in a chain, right? And so once that chain completes on the request, it's going to be sent to a router. The router is then going to route the traffic to a particular upstream. That upstream is then going to respond, and its response is, again, going to go through a series of filters called a filter chain that are each going to do one thing to the response. Maybe it's just adding a metric. Maybe it's actually changing the response. It is up to you. And then it's going to go back through the listener and send a response to the user. So WASM extensibility in Envoy. So Envoy has recently announced that it is going to support being extended through WASM. We'll talk about why we chose WASM here in a bit, but this is a very good thing. There are official SDKs out there for C++ and Rust. So if you're developing with C++ and Rust, you will have a very well-worn path for development, and hopefully it will be very easy to do. There are also unofficial SDKs for Go and AssemblyScript. So, again, a bit more of, not as well-worn of a path, but a path that you can still hopefully easily hop onto. And then because we're developing in WASM, there are many other languages that can compile down to WASM that you can add support for yourself. WASM filters are going to be delivered dynamically to Envoy with the XDS configuration system. So this means it's possible to update the actual filters, that are doing operations on a request, such as authorization, without ever restarting Envoy. So we don't have to worry about, losing any connections or losing any traffic. We're just going to deliver configuration updates exactly as we would deliver configuration updates normally. Without WASM, we would normally have to build our extensions as C++ into the Envoy binary, which means anytime we wanted to update that particular extension, we would have to rebuild Envoy, from the ground up. This is what things like Istio have done, right? They have maintained their own build of Istio, and that's quite a high bar in order to be able to do that. There is also Lua extensions. However, they're generally not as fully featured as C++. There are some things that they can't do, whereas WASM is a fully featured, right, ABI that you can build against. So what is WASM? WASM is actually kind of similar to Java bytecode, right, where it's this generic typed binary that multiple languages can compile to. It was originally built for the browser to sort of be an analogous solution to JavaScript, right? However, it's generally much faster than JavaScript because it has those strict types that are very easily optimized, as well as there's no parsing time, right? So it's very lightweight to deliver and then start executing. So this is, again, very similar to Java, right? Where it's this generic bytecode, very easy to execute and continue. So why would we even choose WASM if it was built for a browser as sort of another version of JavaScript? Why would we even want to use this to extend our proxies? Well, there are a lot of benefits. First off, it's a very isolated environment. So if the WASM filter, panics, it's not going to panic the entire Envoy proxy, right? So the entire proxy is not going to crash just because this particular WASM filter crashed. That's a very nice property, especially when you're an API gateway and you're dealing with untrusted traffic and you may have a bug in your code, right? We all make bugs. So not having to worry about bugs coming in and crashing the entire proxy and only affecting that one request is very useful. Not only that, but we can also limit CPU and memory consumption. So we can validate, that one person can't take up all of the CPU and prevent code from being executed that normally would be executed because one person is taking up all of the CPU. And, if you're writing filters in, say, C++, which is, has a long history of memory corruption bugs, you can sandbox the runtime to prevent these malicious operations from happening on the host environment. So it's a bit safer than just writing a normal C++ filter. There are also many languages that can be compiled down to WASM, right? C++, Rust, Go, TypeScript, right? And a long list of others. So we get support for all of these languages out of the box. So you don't have to go and learn a new language in order to develop a WASM filter. This makes it very easy to extend for everyone. Not only that, but it gives us a chance to be portable, right? So we can validate that, your code isn't just going to work on Envoy, or your code isn't just going to work on another proxy, but it'll work across all of the proxies. So as your infrastructure evolves and as you have new needs, you will be able to migrate your proxies with zero downtime, right? And without having to rewrite any of your code, because you can just port these filters from one to the next. This is a really nice property that we really want to ensure. So what is Proxy WASM? Well, Proxy WASM is that consistent interface between proxies. Right now, there are two proxies that implement this particular interface, right? This ABI, right? And this is Envoy and Apache Traffic Server. So any filters you write using Proxy WASM for Envoy will also just work with Apache Traffic Server, and any Apache Traffic Server Proxy WASM will just work with Envoy, right? And hopefully as time goes on, more and more proxies adopt this. So again, as your infrastructure evolves, right, you will be able to take the same code with you as you move to different infrastructures. So the basic architecture, sort of connecting it back to that Envoy architecture we talked about, right, is there's just going to be a WASM filter inside the filter chain, right? The Envoy worker thread is going to come along, it's going to hit the WASM filter, and it's going to talk to a proxy WASM sort of shim layer. This is implemented by Envoy. Then Envoy is going to pass to your code, which is implemented using the SDK. Your code is going to do something, right? And then return back to this sort of shim layer that will then continue the filter chain. So to describe that in a bit more detail, right, Envoy is going to fire its specific, hey, I've had request headers come in, and proxy, and that little shim layer is actually going to normalize it to something that is consistent across all of the proxies, right? And again, there are official SDKs for C++ and Rust. if you want to write in either of those two languages, you get this nice consistent interface across all of the proxies that implement it. So this is an example filter that sort of goes over what we're going to do, right? So we're going to match on a path, right, that contains private, and if there is private in the path, we are going to check the authorization header, and then we're going to validate it, and if not, we're going to respond with a 401. And this code is going to work across Apache Traffic Server as well as Envoy. It's written in Rust and can be dynamically updated, right? So it's going to be that middle part that sits there. And again, all of those benefits that we talked about of WASM, it's going to be using Node.js's V8. So it's going to be isolated. It's not going to crash Envoy if it crashes, and it's going to have those nice security boundaries that V8 provides.
This demonstration is conducted on Docker Compose-based environment to run services, front proxy, and control plane as Docker container. I developed a simple control plane to deliver WASM code to data planes for this demonstration, which is built on the top of Go control plane, which is a library to build control plane introduced from Envoy community. This control plane is using LDS capability to apply WASM filter to service Envoy by specifying a WASM path, which is uploaded to storage in advance. This is called PCP and it is open sourced. This tool is assumed to share Docker volume as WASM storage in running service containers. This is not for production. We use Ghettoemboy to prepare the demonstration environment. This tool provides the easiest way to get Envoy binary. We can start Envoy without installing binaries by using Package Manager. For example, we can start WASM-enabled Envoy with this single line command. This tool is very useful to verify your Envoy environment. In today's demonstration, we use this tiny service mesh, running blue and green services that have authentication required contents. Authentication service that return JSON Web Token. We provide the API gateway ability via Envoy WASM Extensibility by providing authentication layer written in WebAssembly with internal manufactured Rust SDK to blue and green services to preserve authentication required contents. All of these envoys are provided by Ghettoemboy. Okay, let's start the demonstration. Okay, let's start the demonstration. Make sure the demonstration environment for now. The configurations are like this. Okay, let's start up demonstration environment. Okay, we can find out all of the services are started up. Service proxy in blue and green services are subscribed to control plane, and default configurations are delivered to them from control plane. Let's confirm that we can reach the blue and green services. Okay, let's access to private contents. Currently, we can view private contents, and they should be preserved by some authentication layer. Let's make sure subscribe the envoys to the control plane. This cluster and ID information identifies the subscribed envoy. Okay, let's apply the basic authentication layer to data frames running in blue and green services. This is the basic authentication filters code. This is the main logic of basic authentication. Let's upload basic authentication WASM filter to the storage. In this demonstration, we use this simple Python script to upload it. Let's make sure that the WASM filter was uploaded successfully. Let's apply the uploaded basic authentication filter without terminating envoys. Let's make sure that the WASM filter is applied successfully. Okay, let's access to private contents. Okay, let's request with basic authentication token. Now we can see private contents, and we can see that the basic authentication filter works fine. Next, let's show JOT validation filter and disable the basic authentication filter for now. This is the WASM filter code for JOT validation. This is the main logic of JOT validation. Let's upload and apply the JOT validation filter. Let's make sure that the WASM filter is applied successfully. Let's access to private contents. When we want to request private contents, we need JSON Web Token. Okay, let's publish it on the authentication service. Okay, let's request with extracted JSON Web Token. Okay, and now we can see private contents. We can see that the validation filter works fine. Okay, I showed the WebAssembly capability today. In this demonstration, we can only show simple authentication capability. I hope that you understand the combination of Envoys and WASM extensibility to construct API gateway functionality, such as our later meeting. Thank you. Okay, thank you for listening. Recently, we released a Ghetto Emboy, which has abilities to accelerate our WebAssembly filter development. It provides a boilerplate with internal manufactured Proxy WASM SDK. It supports on Rust. The internal manufactured Rust SDK is built on the top of official Proxy WASM Rust SDK with some conveniences. And the easiest way to build and test WebAssembly filter with Docker container. To run developed WASM filter with Envoy without importing complex commands. In this session, we didn't use this tool, but we want to tell that this tool is a great choice to build your own WASM filter. Thank you for listening.
All right. Thanks, everyone. So we've got some questions here that we'll go through. So the first question I see is, can we build and deploy WASM filters to extend Envoy in an Istio service mesh? And the answer is yes. Istio was actually one of the first adopters of Proxy WASM. They have an entire page set on their documentation site. If you just search Istio WASM, it should pop right up. And they're continuing to do work to make it easier to integrate WASM filters as a user, including introducing new sorts of XDS APIs that make it very easy to distribute WASM filters specifically. The next question I see is development and maintenance of the service mesh / API gateway something all developers in a company end up supporting, or is it handled by a specialized team? I think that depends effectively on the organization, right? It's very much an organizational structure. I think most people, though, end up adopting sort of a hybrid where there is one team that runs sort of the service mesh and making sure it gets upgraded and maintained, and then developers are configuring their services for the service mesh, right? So you have one team who's actually managing the infrastructure of the service mesh / API gateway, and then you have teams that are programming against it. And that's sort of why we brought up in the beginning sort of reducing those two interfaces of having developers have to go configure the API gateway and service mesh. The next question I see is, hi, if I understand correctly, WASM support is not yet officially available in Envoy machine mainline master version. Do you build Envoy with WASM on your own, or maybe you use Istio, which I understand uses a custom Envoy fork? So it is not in the main Envoy proxy / Envoy repository. That being said, Envoy does provide official builds of it for Envoy proxy / WASM. So if you search that, you should be able to find official builds of Envoy. It is opt-in right now. It's not part of mainline. Hopefully it will be merged in soon. But yeah. The next one is how does Envoy communicate to the WASM binary? HTTP, gRPC, TCP, I assume. Ray, do you want to answer that one?
Okay. Next question. Is there a Git repo with this sample code? We don't have a public repository to deploy these sample codes. Sorry.
Yeah, maybe soon, but right now it's dependent on that internal Rust SDK, which is planning to be open, but not yet open. And to sort of circle back, the WASM binary communicates with Envoy over just normal function calls. There's effectively an FFI standard, which is how languages can communicate with different calling standards. And there's some magic that goes on behind the scene, but it's effectively a function call with just a little bit more overhead. But it's not any sort of networking or anything like that. Next question is, would you agree that API gateways are still relevant for reasons like the following? API gateways can be region aware, can route traffic to multiple message. API gateways are mature and API management functionality like publishing open API-based documentation, supporting automatic SDK generation, providing mock endpoints. I think those are certainly useful features of an API gateway. That being said, I don't think they are necessarily the same problems, right? Because ideally, combining those two things, I think, sort of gets you into feature creep territory where you sort of have one thing doing a bit too much. Those are all incredibly useful things to have. I don't know if they necessarily belong in an API gateway. It just feels like a little bit too much to manage at one layer for me. That being said, obviously, I think there are plenty of products that are doing that, and I don't think they're going away anytime soon. But that's sort of what I think. Anyway, looks like another high priority one came in. Sorry, just scrolling through here. Can different WASM code be deployed to different paths? The answer is yes, they can be. So if you remember in the talk, we talked about filter chains. Filter chains can happen per route. So what you can do is you can have a specific filter in a filter chain that only happens on a specific route. So the WASM code will only activate on that specific route. Going through here. All of the stuff we've already considered. Okay, this covered using WASM to implement filters. Are there service mesh features that you need to implement with something else than filters? Or can we do everything we'd want from a service mesh just using that? I think a service mesh provides more than just filters. There's a lot of management that it makes easier, right? So a service mesh is really about controlling all of those sidecars, which you ideally don't want to do from within the sidecar itself. That being said, I don't think it's feasible for any particular service mesh to implement all of the functionality for every single person ever. And so having a way to extend it to fit your specific use case, with WASM, I think this is a perfect use case for. And so hopefully more service meshes pick up proxy WASM so that way this can be used. Ray, do you want to answer, looks like question number 10?
Have you looked at the WebAssemblyHub project to simplify the way you create and deploy filter? Yes, I watched this project. We can use this project to write a WASM code by using TypeScript, assembly script. And it has a WebAssembly hub, and we can deploy the WebAssembly filter to the WebAssembly hub with using this tool.
Yeah, and as we mentioned, sort of our internal Rust SDK earlier, there has been some thought about how we can integrate with WebAssemblyHub there to again make that experience easier. We definitely like WebAssemblyHub. Okay. Is it possible for a filter to use an external service if it's sandboxed in WASM? Yes. The sandboxing is, not something like a firewall or something that would prevent access. Obviously, I'm sure you could configure the sandbox in a way that it did block network access if you didn't want it to communicate out. But yes, by default, filters can talk to external services. Have you tested this approach to scenarios like rate control, for instance? My doubt is the latency cost of running all steps of an API gateway as remoted call services. Ray, do you want to talk about any work that we've done there before?
No.
Yeah, okay, that's what I thought. I just wanted to make sure.
Okay.
So, yeah, we haven't done any extensive testing on rate limiting itself. Our main focus has been authentication. That being said, with rate limiting, as we mentioned, we think it can also provide benefit because not only are you removing, it's not necessarily the network step, but you're removing an extra piece of infrastructure that you have to scale because your rate limiting usually takes a second to kick in because you want to give your users the ability to use your platform well. So that's where those lines came from. I think we can do maybe one or two more. What do you think about the risk of having any networking concern handled by one component that may fail, especially when playing with Envoy filters that can have a wide impact in case of misconfiguration? I think that's a totally fair concern, right? Any particular piece of technology handling too much, I think, can be dangerous. I think the best answer there is making sure, I sort of brought it up earlier in feature creep, is making sure you don't push too much to the networking layer. Ideally, the networking layer should realistically be, it should effectively handle the actual giving the user identity and putting it in a consistent place, retrying, and then authorization, right? And you really, retrying and rate limiting, you really don't want too much more than that. And so I don't necessarily, and obviously I think you may still have some code in your app that does a little bit, but most of the functionality should be handled by that service mesh, and then you don't want to grow it. So I see a lot of people doing, like combining responses in API gateway and service meshes, and that's where I personally get a little bit of a sick stomach because I worry about changing that code, right? Having it handling too much and having it fail. So I think the answer there is, the network is going to fail anyway, so having one place where you have a consistent failure policy is good, but at the same time, I totally agree. I think you need to be careful in how much you push to that layer. Authentication and authorization are already there, so we're not adding anything, but you definitely don't, I think, want to go crazy with WASM filters where everything is handled sort of in the sidecar. So we are going to wrap up now for time, but you can reach out to us in the #2 KubeCon service mesh channel. Myself and Ray will be there for a few more minutes, and I hope you have a great rest of your KubeCon. Thank you.